Welcome to homework.
Okay, so in problem 12, we are given the following information. A random sample of 50 retired men have an average number of jobs they had during their lifetime of 7.2, and the population standard deviation is 2.1. Part A asks us to find the best point estimate of the population mean. So the best point estimate of population mean is the sample mean. So in this case, the best point estimate of the population mean is 7.2 because that is the sample mean. Part B says to find the 95% confidence interval of the mean number of jobs. So to do this, we need to know this formula right here. X bar plus or minus z of alpha over 2 times sigma over the square root of n. So we have everything that we need for this formula except for that z-score. So in order to find our z-score, we need to find what alpha is. So alpha is just 1 minus our confidence level, which in this case is 95%. So it's going to be 1 minus 0.95, which gives us 0.05. And since we're doing a confidence interval and we want both sides of the interval, we have to divide alpha by 2 and we get 0.025. So we need to find the z-score of 0.025. So using your calculator or your z-tables, you can find what the z value is of an alpha of 0.025. And you should find 1.96 is your z-score. So once we have our z-score and we have all the values we need to find the 95% confidence interval. So to find our confidence interval, we have our x bar, which is 7.2, plus or minus our z-score of 1.96 times sigma over the square root of n. I'm going to calculate this side first. So we get 7.2 plus or minus 0.5821. And then I can find the upper limit and the lower limit of my confidence interval. So the upper limit is 7.2 plus 0.5821, and the lower limit is going to be 7.2 minus 0.5821. Once you calculate both of those, you will get 7.782 for the upper limit, and you will get 6.618 for your lower limit. So our final answer is the 95% confidence interval is 6.618 to 7.782. So part C is very similar to part B, except now we're just finding the 99% confidence interval instead of the 95% confidence interval. So we have to do the same thing. We need to find alpha, which is going to be 1 minus 0.99, which gives us 0.01. And then again, because we are doing an interval, we need two sides. So we're going to divide alpha by 2, and we get 0.005. And then we need to find our z-score of an alpha of 0.005, and it is 2.576. Now we have all of our values, and we can just plug them in. So we have 7.2 plus or minus 2.576 times 2.1 over the square root of 50. And again, I'm going to do this right side first. So I have 7.2 plus or minus 0.76503. And then I will calculate my upper limit and my lower limit. The upper limit is going to be 7.2 plus 0.76503. And my lower limit is going to be 7.2 minus 0.76503. So my upper limit is going to be 7.965. My lower limit is going to be 6.435. So my final answer for part C is my 99% confidence interval is 6.435 to 7.965. So part D asks us which interval is smaller, and they want us to explain why. So I've written both of the intervals, and if you look at them, you can see which one is wider. You can see which one has the lowest lower interval and the highest high interval. So if you look at that, this 95% confidence interval is the smaller interval. Now, why is that? Why is the 95% confidence interval smaller than the 99% confidence interval? Well, if you think about it, the 99% confidence interval has to be wider than the 95 because to be more confident that the true population mean falls within the interval, you need to have more values within that interval. And if you draw yourself a normal distribution and you are showing a 95% confidence interval, that means because we divided that alpha by 2, you have 0.005 0 to 5 on either side of your area. And if you are calculating a 99% confidence interval, your interval is going to be wider because all you have on the outside is 0.005 on either side. So that 99% confidence interval includes the 95% confidence interval, because in order to be 99% confident as opposed to 95% confident of the true mean lying within your interval, you need to include more values.